Okay, so let's talk about orbital maps. We've talked about the basics of electron configurations, and orbital maps are those next steps that we're going to take for electron configurations. So let's talk about what actual orbital maps are, how we're going to use them. So orbital maps are a way of organizing electrons to be placed into electron configurations, Bohr models, noble gas configurations, etc. You're going to fill the orbitals as you read from left to right, top to bottom, as you're reading the periodic table. Here is a basic map. If we're just looking at what a map looks like with the base orbitals, there's more to the map than this. But, you know, for quantum number 1, then you have to, that's an s orbital. For quantum number 2, there's an s and a p orbital. For quantum number 3, there's an s, p, and d orbital. 4, s, p, d, f. 5, there's an s, p, d, and f orbital. For 6, there's an s, p, and d orbital. And for 7, there's an s and a p orbital. Okay, so once we understand what an orbital map is, and we haven't talked about how to create them yet, what we have to understand is that when you're looking at the periodic table, it's giving you the information you need to create all of these. And that is for the periodic table of electron configurations. And this is what this periodic table is. So notice here that I have color coded my blocks, and I'm just outlining each of the blocks in a color. So the pink area is my pink block. The purple area over here is my purple block, is my P block. This blue block here is my D block. And then this down here is my F block. Please note that the F block jumps down right here. I've squiggled here and labeled in jump 1. And I've squiggled in here and I've labeled in jump 2 because it jumps down. Now, what's important to note is that each of these columns are always going to have a very similar thing. So this first column here is always going to be S with a superscript 1, because that's saying it's this S block has 1 electron. This column T2 here is going to be always the S with the 2, because it's saying this has an S orbital with 2 electrons. Now note, the number in front changes because this is saying this is the first quantum number S1, this is the first quantum number S2. So this is 2s1, 2s2, because you're changing the quantum numbers. So if you're looking over at the P block, remember the quantum numbers for S and P are your row numbers. You know, this first column here always has 1 electron in the P orbital. This one, the second column here always has 2 electrons in the P orbital. This third column over in P always has 3 electrons in the P orbital. This fourth column over in the P block always has 4 electrons in the P orbital. This fifth column in the P block always has 5 electrons. And the sixth column, not including the helium, because helium, remember, is only in the S block, has 6 electrons in the P block. Now, remember, as you're moving forward, you're going ahead and adding the row number or the quantum number in front of your S's and P's. Now remember, D is your row number minus 1. So although we're in the 4th row, this is 3D because 3 goes back 1. So this is 3D1 because you're just basically adding 1 electron for every single column. And when you jump down, we're in the 6th row. So F is quantum number or row number minus 2. So 6 minus 2 starts with 4. Now, the little superscript I've been talking about, that's the number of electrons that is total. So you're not going to have multiple in any one orbital shell. So if it's 1s1, it's not also going to be 1s2. It's a 1s2, you do not have to write 1s1 because it's cumulative. I'm going to show you how to read this in a second. Let's write these down. Another important thing to make sure you're doing is that you add another area to this for a full orbital. I'm going to highlight those here. It's the N column. So the 4 that I'm highlighting here are your full orbitals. Do it in a color and go ahead and make sure that you're labeling that color as a full orbital. That's going to be an important part of using and finding electron configurations in orbital maps. And now we're going to talk about how to use this to create an orbital map. Okay, so let's talk about the 4 steps to creating an orbital map. This is also a similar 4 steps to creating an electron configuration. So the first thing you're going to do is you're going to find the element on the periodic table and you're going to put your finger on it. Legitimately, put your finger on it. Boink. You're going to list, going from left to right, top to bottom, all the full orbitals before the element. And then you're going to lift up your finger or memorize where that is, and you're going to put what is under your finger down. And we're going to walk you through it. I'm going to give you a second to write down these 4 steps. So let's do a sample problem together. We're going to create the orbital map of phosphorus. So everybody on your periodic table, find phosphorus and put your finger on it. Okay, now let's look how we're going to read this using our periodic table of electron configurations. So the first thing is to remember that we're talking about full orbitals. So make sure that you have your full orbitals outlined. I know I wasn't able to upload one that had the full orbitals outlined, so I'm outlining them now. And your first step is to always put your finger on the element. Phosphorus, I put a blue dot on it or a green dot on it because I couldn't, I can't physically put my finger on it. So the green dot is putting my finger on it. And then your next step is to list all the full orbitals before the element. Now, remember, you read a periodic table like you read a book, left to right, top to bottom, left to right, top to bottom. So I'm going left to right. We know that S will hold 2 electrons. So 1s1 is not a full orbital. So I go left to right. Oh, 1s2 is my first full orbital. There's my first full orbital. Now I'm going to keep moving forward, top to bottom. So I've got to read the next line of the periodic table just like you would read the next line of a book. So 2s1 is not my full orbital, but 2s2 is. Going left to right, so I keep going along the row. My next full orbital, as we've outlined and know, are the last columns of every orbital block. So it would be 2p6. Then we have, again, we are not at phosphorus, so we keep reading. We have 3s2. Then you keep reading and you go, oh, I have no more full orbitals, so I'm going to lift up my finger and write what's under my finger. So I'm clearing my drawings. So then how you set up an orbital map is you figure out what row you're in. Someone tell me what row we're in. Yep, we are in row 3. So you make 1, 2, 3 rows on your orbital map. You always match the row you're in. Then in row 1, what is our full orbital? It's 1s2. So on row 1, we write 1s2. And then in row 2, we have 2s2, 2p6, and that's what we write in row 2 for our full orbitals, 2s2, 2p6. In row 3, we have a full orbital and a partially filled orbital, so we write 3s2. Then what you have to do is write in that final partially filled orbital. So you lift up your finger and you have 3p3. That's phosphorus. So you write 3p3. And here's a good check. You look at the atomic number of phosphorus as being 10. Am I right? Nope, I'm not right. I don't have a periodic table in front of me. Apologies. Where did wander off to? As being 15. So the atomic number of phosphorus is 15. So if you add up all the little numbers, you should be able to get 15 because you're counting all the electrons, and all the electrons have to add up to the atomic number. So 2 plus 2 is 4, 4 plus 6 is 10, plus 2 is 12, plus 3 is 15. We have a proper orbital map that will lead us to an electron configuration. So let's now do another example. Let's look and complete the orbital map for Cobalt. So everyone take a moment and find Cobalt on your periodic table. Go ahead and put your finger on it. Now, you can go ahead and start your orbital map by listing on a sheet of paper 1 through 4, 1, 2, 3, 4, because we are in row number 4. Then we start reading the full orbitals from left to right. We are reading from left to right. So 1s1 is not a full orbital, so we go all the way over and we have 1s2. What is this doing? Then we have, remember we read left to right and then row by row, just like we read a book. So the next row, the next full orbital is 2s2. And then you have 2p6. And I know they flew in differently. I'm not sure how to correct that. I apologize. Then you keep reading. Then you have 3s2. Then you have 3p6. Then you have 4s2. So now when you're filling in your orbital map, you're organizing it by quantum number, not row number. The row numbers only work, remember, for S and P. So then when we go back to our electron configuration, remember, you have to figure out where Cobalt ends. Cobalt ends here on 3d7. You're not going to be putting it in column 4. You're going to be putting it in quantum number 3, because remember, 3 quantum number is row minus 1. So you end up with 3d7 in the 3rd quantum number because you organize your orbital map by quantum number, not row number. So let's do the orbital map of gadolinium. So everyone find gadolinium and put your finger on it. And it's way down here in the F block. I'm going to help you out here, because I want to show you how to do a jump. So once we have our finger on it, you write all full orbitals before the jump. So when you're in the F block, you write all full orbitals before the jump. So remember, going left to right, top to bottom, we are in row 4 here. So we jump down in row 6. So we really do have to write a orbital map with 6 rows going down. And we're going to organize it with all your full orbitals. So reading left to right, top to bottom, we're going to outline all the full orbitals to our jump. So left to right, our first full orbital is always 1s2. Our next full orbital is 2s2 followed by 2p6 because it's the 2 on this row. The next full orbital is 3s2. The next full orbital is 3p6. The next full orbital is 4s2. Then you go to 3d10, then you go to 4p6. Then you go to 5s2, 4d10, 5p6, and 6s2. Now those are all the full orbitals before the jump. And remember, when you're doing your orbital notation, you're going to go ahead and organize it by full orbitals 1 through 6. But here's the trick when you're jumping down and staying. The trick is staying in the F block. You jump down after 5d1. And in order to account for all the electrons, you have to also account for 5d1. So when you jump down and stay in the F block, you're going to have 2 orbitals that are partially filled. The D block, the 1 electron before you jump down, and then the F block. And remember, when you organize these, they're always completely organized, not by row number, but by quantum number, and that is a number out front. So remember, this 5 in front of the D is its quantum number because D is rho minus 1 for the quantum number. The quantum number for S and P is the row number, and the quantum number for the F block is rho minus 2, where that row is the row where it jumps down. So it jumps down in the 6th row, so it's in the 4th quantum number. So when we're going to write our electron configuration or our orbital map for our electron configuration, you have to include all 6 quantum numbers and everything's full. And remember, you're organizing it by your quantum number. So in quantum number 1, we had 1s2. In quantum number 2, we had 2s2 and 2p6, which we wrote right here. In quantum number 3, we had 3s2, 3p6, and 3d10. So we wrote that here. In quantum number 4, we had 4s2, 4p6, and 4d10. So that's why it's all written in that quantum number. In quantum number 5, we had 5s2, 5p6, and then we had to include this 5d1. So we include that there. And then we went all the way down to 6, so we had to do 6s2. Okay, when we're all the way done, you lift up your finger on the F block, and we're at 4f7, and we write that in the 4th quantum number, and this is your complete orbital map. Okay, let's do some practice. I want you guys to take a moment and complete the orbital maps for the following elements: sodium, bromine, lanthanum, and polonium. I'm going to go ahead and give you just a few minutes. I have for sodium, there was in the 3rd quantum number, or the 3rd row, because remember the quantum number and the rows for S and P are the same. So we have to represent 1, 2, 3 quantum numbers in rows on our map. Now, if you have your finger on sodium, you know it's in the 3rd quantum number. So before that, before we get to sodium, we have to write all the full orbitals ahead of it. And remember, you read it from left to right, top to bottom. So the first full orbital in quantum number 1 is 1s2. Then we have to go to quantum number 2, or the 2nd row. Then it's for 2, then we have 2s2, then 2p6. And then for sodium, it's in the 3rd row, 1st column, so it's 3s1. The atomic number of sodium is 11. So we can check our answers to see if this adds up to 11. So 2 plus 2 is 4. 4 plus 6 is 10. 6 plus 1 is 11. This is the correct orbital map for sodium.